Let's hit the math. You know, compared to the intuition, the math, I think, is always pretty easy. The way to get the coefficients, well, firstly, you need to find out what are we really trying to do. What we're really trying to model is an arbitrary f of t as being composed of a DC term plus the sum of an infinite number of sinusoids. And we'll model these sinusoids for this first class as being a sum of a cosine and a sine. And we'll say it's a sub n of our cosine, n omega naught t, plus b sub n of our sine, n omega naught t. So you'll notice that just like our intuition said, we have our fundamental frequency. When n equals 1, that's our fundamental frequency. This is the frequency of our signal, of our periodic signal. And we're going to add, maybe it's easiest for you to see it as written out. Here's our fundamental frequency. And then here's our second frequency. This is times 2 omega naught t plus, and then higher and higher as you go. So all we need to do to decompose it is to find our A naught, our A sub n's, and our B sub n components. And we need to find one A sub naught, an infinite number of A sub n and B sub n components. Oh, and then for the overall thing, we also need to find what the omega naught is of our waveform itself. So once we find all those, we're set. And let's start off by finding the omega naught. So to find the omega naught, what we're going to do is to isolate one period. And that could be any period of your waveform of x of t. And you're going to find the time period, the fundamental frequency in hertz, and then the fundamental frequency in radians per second. And so let me give an example of this with the very waveform we've been doing so far. We've got this waveform that looks like this, where this is goes between +1 and -1, and it's at this is -1/4 over here, and this is 0, and this is I'll write it down here: 1/4, 1/2, 3/4, 1. And so a very simple way of writing one period would be f of t. We often call this the generator function, f sub g. You could say it's equal to 1 between 0 is less than t is less than 1/4. -1 for a quarter is less than t is less than or equal to 3/4, or 1 for 3/4 is less than t is less than 1. And that's a correct statement. A little awkwardly drawn. Let's try that again. But that's not the best way to do it. What's a simpler way to write one period of this? Chow? What's the way we could write one period of this with only two different sections? We can take any period we want to. For this first one, we tried taking a period from, we tried taking a period from here to here, from 0 to 1. And we found out it had 3 sections. What's another way to define it so we don't have as many different sections? Aiden, can you help him?
Would you go from -1/4 to 3/4?
Yeah, that's it. Go from here to here. And if you do that, you'll only have two sections to define. So that's 1 for negative 1/4 is less than t is less than 1/4, and negative 1 is from 1/4 to 3/4. Okay. There's a few other things you want to do too. You want to, you've isolated the one period now, and you're going to find t. So just by inspection, what is t? Sabine?
Is it the period?
It is the period. And what is the period for this particular one?
1. Is it 1, sir?
Yeah, exactly. And then if you know the period is 1, then the frequency will always be 1 over the t, always. So for this particular example, it's 1, and then its omega naught will always be equal to 2 pi times the fundamental frequency. So for this particular one, it's 2 pi. But the parts where it's always true is those things are always true. And so now we've done step 1. Step 2 is you're going to find A naught. And A naught, you can figure it out a number of ways. A naught is the DC constant term. You can figure out mathematically. It's equal to, this looks like a capacitor, doesn't it? It's 1 over the time period times the integral. And this weird thing means the integral over any time period you want to. So you could do between 0 and 1, but it'd be smarter to do it between negative 1/4 and positive 3/4 of your function dt. So for this particular example, this would be equal to 1 over 1 times, we're going to have to break this integral up into 2 parts because we've defined it over 2 parts. So one part would be between minus 1/4 and 1/4, and whatever that function is there, so the function here is 1 in that area, plus the integral over the rest of the period, and it's negative 1 in that area. And hopefully it's clear that the integral of 1 over 1/2 is going to be equal to 1/2 minus 1/2 equals 0. So that's how you did it by math. But there's, I'm a big one for doing things intuitively whenever you can. The intuition is that this is just the average. So you can look at this and say, hey, this is just an average of 0. There's no average value. Now you need to come up with your other parts. You need to come up with your a sub n values. And the formula for a sub n is 2 over your time period times the integral, again, over any time period of your function. Now check this out. Your a's correspond to how much cosine you have in your waveform. So when you go to figure out your a's, you're going to multiply it by cosine n omega naught t. So this is one for your study sheets, and this is one for your study sheets. And I'll work this out very briefly here. For this particular example, this would be 2 over 1 times, we're going to have to break that integral up into 2 different parts. So it's minus 1/4 to 1/4. F of t is positive 1 here. So this would be times cosine of n omega naught, which we said is equal to 2 pi t dt. And then to that, we will add and then to that, we're going to add an integral from 1/4 up to 3/4 of negative 1 cosine of n omega naught t dt. And when we do I'm completely fine with working the integrals out. Does anyone want to see me work it out? Let me just start it off, the integral for this thing. The integral of a cosine is going to be is it a positive sign or a negative sign? Preston?
For the first integral?
Yeah, is the integral of a cosine positive, or it's going to be sine, right? Cosine goes to sine goes to cosine. But is it positive or negative for the integral?
I believe it's negative, but
Yeah, you're thinking derivative. The derivative of cosine is a negative sign, but the integral is a positive sign. So it's equal to sine of n to pi t. And then using the chain rule, we've got to say 1 over n to pi. So that when we take the derivative, that n to pi cancels out. And we're going to evaluate that between t equals minus 1/4 up to positive 1/4. And then to that, I'm going to bring this minus 1 out. So we're going to subtract, and it's going to be the same thing over here otherwise. N to pi sine of n to pi evaluated between t equals 1/4 to 3/4. And skipping the algebra, it'll all boil down to 4 over pi. To find a sub 1, when we substitute in 1 for n, it becomes 4 over pi.
Hey, so I have a question.
Shoot.
For your second integral, number 3 there, where you have the integral of 1/4 to 3/4, -1 cosine of what? Omega 0 t? What is that before? Is that 0? What do you have right there?
Are you talking about down here?
Nope, up and to the right. All the way to the right. Last integral. What is inside there for the cosine?
And yeah, let me rewrite that a little bit more neatly. I'm running out of space on my screen. That should be, it's the same thing as what's to the left. That should be cosine of n to pi t dt. So you can figure out for higher values of this too if you wanted to. If you put in numbers, this would be about 1.27, which favorably compares to what Jonathan guessed as 1.5. And my point in doing this is that the integrals get nasty, right? You can always just throw it in your calculator and ask you to get a numeric value, but check with your intuition, see if it's about right. Without knowing anything at all what he was doing, Jonathan guessed within better than 15% of the correct answer, just by looking at it. Okay, and you need to also know how to figure out your B sub n's. I'm not going to work out the math. It's very similar for that. Your B sub n in general is the exact same thing as your A sub n, except you're going to use sine. And so this is the key formula to keep from that. Now, if you want to take a picture of that, you can before we move on to the next screen. Now, this is one way to take the Fourier series. This is called the A sub n, B sub n form. It's also called the cosine sine because you're creating your waveform out of a group of cosines and sines. It's also called the rectangular form for reasons that'll become clear later. But you could graph your A sub n's on, say, the horizontal axis and your B sub n's on the vertical axis.